Hi friends, this is Rashekar, a GET faculty for electrical machines. Today in this video, we are going to discuss about Delta Zig-Zag Star Connections. Let's discuss about zigzag connections. Let's see here. Generally, we have two types of zigzag connections. One is the Delta Zig-Zag Star and other one is the Star Zigzag Star. Delta Zig-Zag Star and Star Zig-Zag Star connections. Because generally in these two cases we don't have a delta in the secondary. That's why the EMF is not sinusoidal. EMF is not sinusoidal in delta delta and star star. EMF is not sinusoidal in delta delta and star star. And here neutral point is floating. Neutral point is floating in star star. These are the disadvantages and difficulties of delta star and star delta. Because there is no closed path, no closed path for third harmonic currents, no closed path for third harmonic currents. That's why we are modifying this as a zigzag connections. As a zigzag connections. In generally, the third harmonic components are co-phasal in nature. Co-phasal in nature. That's why in zigzag connections we are providing series subtraction method of addition. Series subtraction of windings. Which cancels the third harmonic currents, because of series subtraction of windings. Hence, now the phase voltages are free from third harmonic currents. When the phase voltages are free from third harmonic currents or third harmonic components, then our EMF is sinusoidal. And here the stable neutral is possible. Stable neutral point is possible by using zigzag connections. In zigzag connections, we are providing series subtraction of windings. Due to this series subtraction of windings, what happened? The third harmonic currents are eliminated because of co-phasal in nature third harmonic currents. Then the phase voltages are free from the third harmonic currents. Hence, the EMF is sinusoidal and the stable neutral point also possible. These are the advantages of zigzag connections. In generally, the zigzag connections are used for unbalanced conditions only. Zigzag connections are used for unbalanced conditions. This is the overview about zigzag connections. Let's draw the zigzag connections. Let's draw the zigzag connection diagrams. Let's see, take the first one, Delta Zig-Zag Star. Let's take the Delta Zig-Zag Star. First take the Delta Zig-Zag Star. See here, I am drawing the connection diagram for Delta Zig-Zag Star. Let's see. First here we have to take delta in the primary. So in the primary we are taking delta. Connection. This is A2, B2, C2, A, B, C, A1, B1, C1. This is delta for primary. Next, go for zigzag connections in star. Zigzag connections in star, that too in series opposition, series subtraction of windings. So let's see, the secondary winding is divided into two parts. Secondary winding is divided into two parts. Secondary winding is divided into two parts. This is A by 2 and this is A by 2, B by 2 and B by 2, C by 2 and C by 2. These are the secondary star. We have to make it star. And here A1, A2, A3, A4, B1, B2, B3, B4, C1, C2, C3, C4. Always the dot notations are at these terminals only. This is the secondary winding. Now we have to make it zigzag connection. For that zigzag connection, see what I am doing here. This A1 is connected to B3. This B1 is connected to C3. And this C1 is connected to A3. C1 is connected to A3. And this is a star, right? So here make it one star. Here make it one star. This is actually my neutral. This is generally the zigzag connection. The zigzag connections of star. Delta zigzag star. Let's draw the arbitrary vector diagrams. We know the arbitrary delta how is. This is A and this is B and this is C. A2 to B2 A, B2 to C2 B, C2 to A2 A. This is the arbitrary delta. Now let's draw the arbitrary zigzag connection here. Let's draw the arbitrary zigzag connection here. First see here, these are in series subtractive. These are in series subtractive. So here A is in like this. A is like this. But here from the neutral, A is like this in opposite direction, A by 2. And B is like this, here also in opposite direction, B by 2. And C is in upwards, here C is in this direction, C by 2. What are these terminals? From the neutral, B3, from the neutral, C3, B by 2 is connected to C3. From the neutral, A3, C by 2 is connected to, this is the first one. And next one, this. See here, these are subtractive in polarity. These two are in subtractive polarity. These two are in subtractive polarity. But these two are in additive polarity. Sorry. These two are in additive polarity. One, see here. These two are in additive polarity. These two are in subtractive polarity. I taken for subtractive polarity. Now these two are in additive polarity. So for additive polarity, first from A3 to A4, A by 2. B3 to B4, B by 2. C3 to C4, C by 2. Additive polarity nothing but in phase. In phase. See here, my A is here. My A is here. Here also A should be same. Here also A should be same. And my B is here. Here also B should be same. And my C is here. Here also C should be same. From where? First of all see here A to the B. Nothing but from B3 to B by 2. Where is my B3? This is B3. This is B3. From this, here A by 2, right? Here A by 2. B3 to B by 2 for B4. Where is my B? My B is like this, right? my B is like this. So in same direction, listen carefully, where from B3 to B4, B3 to B4, B by 2, B3 is there, B4, my B is in this direction because of additive polarity, because of additive polarity, this is B4, B3 to B4, B by 2. This is the final B. This is the final B. Is it okay? And next one, this is final B. And next one, where is that? From C3 to C4, C by 2. C3 to C4, C by 2. Where is C? C is here. From here, C by 2. Where is C? This is my C, right? Upwards. So exactly in parallel. Exactly in parallel. This is C3 to C4, C by 2. And this is our C. This is our final C. This is our final B, right? This is our final B, and this is our final C. This is our final A, B, and this is our final C. So next one is A3 to A4, A by 2. Where is A3? B3, C3. Sorry, this is A3, right? Once check it, this is A3 because C by 2. C by 2 is connected. C by 2 is connected. This C by 2 is connected for A3, right? This C by 2 is connected for A3, A3. So from A3 to A4, A by 2. Where is my A? My A is like this. My A is like this. So here also, A should be in same manner. Here also, A should be in same manner. Let's see. A in same manner like this. This is A by 2 for A4, and this is our final A. A, B, C. Again clockwise direction, no problem. Phase sequence is followed. So this is A, B, C. This is the final vector diagram. Now superimpose these two. Now superimpose these two. This is 12 o'clock, this is 6 o'clock, and this is our reference. Always this is our reference. Always this is our reference. This is capital A. And see here, our small a in downwards exactly. Our small a is in downwards exactly. This is small a, and the phase shift is 180 degrees. So delta zigzag star gives us 180 degree phase shift. Delta zigzag star gives us 180 degree phase shift. This is the zigzag connections. Here, see here, series opposition. The A1 is connected to B3, B1 is connected to C3, C1 is connected to A3. Due to this series opposition, the third harmonic currents are eliminated. So this is a one configuration. In this delta star, we have another configuration also. Let's see that another configuration. What is the phase difference for that configuration? Let's check it once. So see, this is 100% same. There is no change in primary. But in secondary, some differences are there. See, let's see that differences. Let's see that differences. I am drawing again. I am redrawing this secondary zigzag connection. One is for 180 degrees. Next, second, how it is. Once check it. Again, take the two windings. Again, take the two windings. Like this. These are two windings. We know this is A by 2, A by 2, B by 2, B by 2, C by 2, and C by 2. These are the different windings. And next we know this is A1, B1, C1, A2, B2, C2, A3, B3, A3, B3, C3, A4, B4, C4, and always the dot notation at these terminals. Right. Now we have to again connect them in series opposition. One series opposition completed. Next, what is the possibility to add in series opposition? This A2 should be connected to B4. This B2 should be connected to C4. Right? This C2 should be connected to A4. This C2 should be connected to A4. This is the another configuration. Let's draw here the arbitrary vector diagram. See, these two are in additive manner. These two are in additive manner, but these two are now subtractive manner. Reverse. These two are in additive manner because here star, right? So we have to make it star first of all, right? We have to make it star. This is my neutral. This is star and neutral. Now these two are in additive manner and these two are in subtractive manner. So see, these two are in additive manner. So where is my A by 2? This is my A by 2, A by 2, A by 2 in the same direction of A from the neutral, A by 2. And this is my B from the neutral, B by 2. And this is my C from the neutral, C by 2. These are the vectors. And now tell me, where is my A by 2? A by 2 is connected for B4, and B by 2 is connected for C4, and C by 2 is connected for A4. A4, B4, C4. Right, it's completed. Now it's completed. Next one. This additive is completed. This subtractive is remaining. Additive is completed. Now subtractive is remaining. Additive is completed. Now subtractive is remaining. Let's see how the subtractive is there. First, from A4 to A3, A by 2. A4 to A3, A by 2. This is my A4. From A4 to A3, A4 to A3, A by 4. Where is my A? My A is in downwards. So here the A should be in exactly upwards. This is A3 and this is A by 2. See here, exactly upwards, A3 and A by 2, A3 and A by 2. What is this? This is A3, this is A3 and this is A by 2. Now this is our actual A. Okay. Next, from B4 to B3, B by 2. From B4 to B3, B by 2. Yes? So where is my B? My B is like this. So here also my B is like this. Here also it should be in opposite direction. Because subtractive manner, right? Opposite direction. So exactly like this. From B4 to B3, B by 2. And this is actually B. And next one, C4 to C3, C by 2. Where is my C? C is in upward direction. Here C should be in downward direction. Exactly in downward direction. C4 to C3, C by 2. And this is our actual C. This is my star. Delta and star. Now superimpose these two. Superimpose these two here in the same clock. Superimpose here. My capital A is again at 12 o'clock. My small a is also at 12 o'clock only. Nothing but it gives us a 0 degrees displacement. Like a delta and the star, the delta zigzag star also gives us either 0 or 180 degree phase displacements. Like a delta, delta and star, star, delta zigzag star also gives us 180 degrees or 0 degrees displacement. This is the zigzag connections of transformer, delta zigzag star. And see here also the phase turns ratio x is to 1, no doubt. But what is the line turns ratio? What is the line turns ratio? So let's check the line turns ratio for this. Let's check the line turns ratio for this. Let's check the line turns ratio for this. See here, for this line turns ratio. Here, line voltage of delta is equals to phase voltage. And line voltage of this zigzag star is equals to root 3 times of phase voltage by x. This is zigzag star. Line voltage of delta is equals to phase voltage. For zigzag star, the line voltage is equals to root 3 times of phase voltage by x. Root 3 times of phase voltage by x. What is the phase voltage? This is phase voltage. This is phase voltage. Here V phase is equals to this one and plus this one with 120 degrees. Nothing but square root of V by 2x. X is this one. Or I am taking directly V by 2x whole square plus again V by 2x whole square plus a square plus b square plus 2ab cos theta. 2ab cos theta. What is the theta between them? 120 degrees. What is theta between them? 120 degrees. If you calculate this, if you simplify this, the phase voltage of this zigzag is root 3 V phase by 2x. Root 3 V phase by 2x. It will come root 3 V phase by 2x. If you simplify this value, you can get root 3 V by 2x. Root 3 V by 2x. Just calculate it. So now see what is the line turns ratio. What is the line turns ratio? The phase gets cancelled. So the line turns ratio is x is to 3 by 2. Line turns ratio. Line turns ratio for zigzag connection is delta zigzag connection is 3 by 2. X is to 3 by 2. X is to 1.5. X is to 1.5. This is the delta zigzag star connection. Delta zigzag star connection. This is also important. They will ask you question. Did you understand? Right? Thank you, sir.